Hey everyone, welcome back. In this video, we'll be covering how to use Redis as a cache system in our existing Node.js backend system. I have a real-time example where I've been working with one of a freelance project and one of the dev got encountered with this a lag in the response time because they're trying to calculate the data dynamically on demand and it's not a viable solution. So it's kind of a Instagram followers and following system. So for any profile, we just need to retrieve the number of followers and also the number of following people, right? Before diving into the project, actually I just want to share some different caching strategies. So there are like quite couple of you, but I'll just cover the main prominent three types of cache strategies. So one is like cache aside. Application or any microservice can call one of the microservice or a server, right? As a HTTP request, let's say. Now that request itself is kind of a very data intensive and it's not kind of a more often changed, though if it is often changed, but still we can do caching to some extent, right? Now first server queries Redis to get that information. If it couldn't find that information, then it will basically ask database. So once server receives the actual data, it will again save that to Redis. For the next subsequent queries, the data will be there in the Redis, so we'll just return it instead of querying from the database. There are some caveats like on what basis, like how much of volume of data we need to store, and if, can we set any expiry. So if we set an expiry, then there is a chance of not actual real time. So there are some trade-offs we can do, but again it purely depends on the business use case, right? And moving on to the next cache strategy, that is write through cache. So in this case, so application microservice service again calls server first checks in Redis. If Redis it is there, then it will immediately return. And let's say for the write operation, right? So for the read, it will be always be directly from the Redis and it immediately returns. So it will actually don't read from the database. But for any write operations, it updates in Redis and also again updates in the database. You might think like, is it really necessary? Well, actually, no. There are few certain specific use cases where we need to do this, and that too for a very small data, because if you try to do it in a very big data, then Redis itself, it's like kind of a very big data. It gets ended up with a very big volume of data, and it's kindly and it's kind of not really the right way of approach. But there are few actual use cases where this can be used, but it's like very limited. And moving on to write back cache, this is kind of like similar to write through, just that so at least in this case, the first will write to Redis and immediately will try to write to database also. Okay, but in this it just updates to the database asynchronously. So now if you see, the source of truth actually relies on the Redis itself, and there are so many drawbacks in this case, because what if during the update from Redis to database, as it's an asynchronous, what if the Redis database crashes? Then we lost the actual delta data, so that's kind of not reliable. So these are like a basic like a most often used cache strategies: cache aside, write through, and also write back cache. So in our example in this video, we'll be covering cache aside with a simple use case. So let's get started. Now I'll just walk you through the current implementation. If you see, it's a simple Express.js app, and we have one get request user ID. So we'll try to get the stats based on the user ID. This user ID is again the MongoDB object ID. um, Let me just open the models. I think that would be clear. So if you see here, I just defined two models: user schema and also user follower schema. So if you see, email, full name, DOB, that's it, three fields. Just for the sake of video, I just created this mini app. And user follower schema also. Now in the user follower schema, it's simply like from user ID and to user ID. So from which user follow request has come to which user, that's it. Okay, so to user IDs again points to the same object ID of this underscore ID of this user collection, right? Simple. So if you see here, get users user ID and stats. So if you see, I'm currently doing two queries, two independent DB calls: count documents of to user ID of user ID and also from user ID of user ID. Now if you see, let's say there are like five users, and series would be, let's for simple terms, 1 2 3 4 5. Now if I call give me stats for user 3, now this first line will tell you like, okay, how many followers for that user 3. Okay, now if you see the second query, this is like from user ID of for that value 3. So this will give you all the users where user 3 is following to, like the count basically. And it's simple object follows count and following count, that's it. Okay, simple. So now let me just start over. And to set it up in my local machine, I'm using Windows for the sake of videos, but I'm not a Windows guy, I'm purely Ubuntu. But let me just try to give you some gist. So I have a Docker, right? So I already running MongoDB instance, Okay, at the same default 27017 port. And if I can just simply oops, I can just simply start npm start localhost 3000. Right now I already have the postman also open with a proper things. There's like one of the random user id I just picked from the database. So let me just first run the query, then we'll actually go through the db structure. Okay, if you see here, on an average it's taking like 1000 milliseconds. Okay, now let me just call again, close to 1000 milliseconds. Right, okay, now I'll just show you the database users. So if you see here, email, full name, dob, I just fed the data with a faker. uh, Around, like if you see here, this is like 2.3 million records, and user followers is also around 2.6 million records. So what I did, I just randomly picked one of the object id and I just kept it, placed it over here just to retrieve the stats for that. So we can do something similar. Maybe if we can just quickly skip, maybe 100,000, right? Because we have like 2.3 million and limit is like maybe 10. And let's run. So we'll just pick this one, E3P, because if you see, maybe the other way also should work. So user followers, right? So based on my feeding logic, but let's query this one for now, right? User ID. Let's call this directly and see. Let me just quickly change this and send. Right. So if you see in this case it's only one, maybe we'll just pick the other one. If we just get some random data. Okay, so follows count is 0, following count is 2, maybe something else. Okay, so this is like 1 and 0, one final trial, just to get some more different data. All right, then let's head back to the default value of CF. I think this guy has 3 2. Okay, cool. So this is taking around 1000 milliseconds. I hope this it's clear till now, right? So we just simply have a express server, right? And I'm doing two queries to the user follower based on these two requirements, to user ID and from user ID. I'll just get the followers count and also following count. So yes, we can do a small optimization. We can do the aggregation in the Mongo and just extract these two directly in a one single DB call. But the whole idea of this video is to showcase you how a typical any REST API, if it is taking so longer time, how we can introduce Redis so that we can save that response time, and also based on the different cases how we can do the different cache strategies and all, right? So okay, so that's all. This is clear, I believe. So what we'll do now, we'll just introduce Redis. So I already have the Redis bootstrapper kept in place. So just a create client console.log on the on error and also on the connect. I'm just connecting. That's it. So don't judge me on the way how I'm using connect and all. It's a plain file, but ignore that because that's not the focus area for this video, right? So let's quickly import Redis. Okay. Now what we can do over here, right? Before even calling DB calls, we'll just see if we can get cached records. Okay, cached record redis.get. We'll just simply call user ID. Okay, that's it. So the key would be user ID. I already opened um, Redis stack UI so that we can actually look at the data inside the Redis. I think I need to start the Redis also. So let's start this one. And from the UI, let's refresh. Oops. Okay, it's all synced. Now let's get back to the code. So on the cached record, if it exists, right, we can just simply return as is. We don't need to query. Okay, rest.json, and as it's a plain simple get query with the expected pattern as string, so we just need to pass that into a proper JSON. Yeah, that's it. So if you see at the cache aside logic, so first we'll fetch, I will ask for from the Redis. If the record is found, we'll just immediately return that to the application, right? If it is not the case, then we'll first request from database. Once it gets once we receive the data, then again we need to save that into the Redis so that whenever in the next subsequent calls, it will skip the database call and it will just blindly call to the Redis, and if the record exists, it just returns. Okay, so now let's say Yeah, so once this is done, now in the second case, if the record is not found, so once we fetch the data, right, stats. Now what we can do over here, we can actually save to Redis, right? Set. Okay. We can call user ID as a key, and we need to just stats. That's it. And in the options, we can pass the expiry. That's like 1 hour, 3600, and NX true. So set this only if the key doesn't exist, otherwise just ignore NX true meaning. So EX is like expiry, and that is like 3600 seconds. That will be 1 hour. All right. So we are saving it and then we are returning. That's it. Just a couple of lines. So we are getting the Redis. First, we are checking at the cached record, like if the record exists in the Redis. If it is, then we just return it. Else, once we get the data actually from the database, then we are setting over here with an expiry of 3600. So let me quickly start. You see, connected to Redis, connected to MongoDB. Now, for the very first time, it would take a while because it's not there on the Redis. Now, let's run it. Oops, there was an error. Let me quickly see what was the error. Is not a valid JSON stats JSON dot stringify. Oops, sorry, that would be a proper promise, right? So it is returning a promise. So we should be a bit cautious. Okay, I think now it should work. Yeah, so it is taking almost 1000 milliseconds. Now if we just refresh over here, now we can get this key here, like with this user ID, follows count is 3, and the moment of truth, if we just do it for the second time, it's 4 milliseconds. So we decreased all the way from 1000 milliseconds to a single digit. That's on an average of 3 milliseconds. This time around it's 3 milliseconds. So the data is all fetching from the Redis. It is not going to the database to get the information. Now if I just refresh over here, so the TTL is nothing but the time to live. Like we set this to 3600 seconds, right? So that's like 1 hour. So if I keep refreshing, the value, the seconds keeps decreasing. After 1 hour, it will be deleted. So after that, again, it goes to the same path, if at all, if it's like a more subsequent query. Yeah, I hope that is clear. So this is one of the cache strategy pattern we followed, that is cache aside. There are other two, and as I said, there are, it's kind of, it doesn't make sense in our use case, because if you see here, you might ask that, okay, Vivek, what happens if someone is following the same user, like new user has followed up. So what we can do, right, this is get request. So let's assume we have another, obviously we'll have another API like post, like add follower to this user. So what we can do is, the moment we get that information, we can actually update the cache. We'll get the stats again, right? We'll get the stats once we added the count. We'll get the stat and stats for that user, and we'll just simply set again with 3600, right? So that every time for any write operation, we are making sure that if at all, if the key exists, then basically update the key in the Redis with the correct information. We can skip, let's say for a user who has like 1 million followers, right? Now another one single follower added to that user, doesn't make really sense to keep updating every time, because if it's kind of a celebrity guy, then he keeps getting more followers every second or every minute or something like that, right? It's not a good idea in that case, where we need to keep updating the Redis cache again and again. So it's okay, so it's like a cache thingy. So we can decrease the expiry. Instead of 1 hour, we can just make it as 30 minutes, something like that. So it all depends on the business use case, how we need to craft this cache system into our existing backend system. That's all for this video. If you have any questions, concerns, or doubts, feel free to drop a comment. Thank you so much for watching. Happy coding.